Now, um, we will start with the Daniel cell, but before we even get started, I'll show you and I'll send you after this lecture like two videos showing the Daniel and galvanic cells separately. So let's move to the Daniel cell and see like what happens inside the cell. For the Daniel cell, the basic component of Daniel cell are a piece of zinc submerged into ZnSO4 solution, so which is the positive pole that the oxidizing process goes into it. So an oxidizing, or let's say like it would be reduced for here, and a copper like piece of plate submerged into CuSO4. So like the element is submerged into its salt. Okay, so Zn into ZnSO4 and Cu into CuSO4 solutions. So the negative pole that the reduction or reduce process goes into it. So when we say like Daniel cell, you should know that with Daniel cell there's Zn into ZnSO4 and Cu into CuSO4. This is like fact, okay? Third one, external wires. So this is the components, like it depicts the apparatus of the cell, or the sketch, let's say, or how to draw the cell. So we have two pieces, the cathode and the anodes, and we have an external wire used for the transformation of the electrons from the anode to the cathode, okay? And we have a salt bridge. So this is really important. What is a salt bridge? It's a glass of cylinder. It's like the U letter, as you can see here, shape, okay? Upside down. It consists of an inert electrolyte solution that is fixed or steady, doesn't move, inside the cylinder by a substance called agar that is used for the complete the electrical circuit and the complete or the connect the solution of the two poles without get them mixed. So it's like a connection, we can say. So a salt bridge is a connection between like two containers. One of them has the Zn so far with Zn as the pole, the positive pole, and the negative pole, which is the Cu into a Cu solution. And this salt bridge is a connection or between the two like solutions, okay? It does not like allow two mixture to two solutions to get mixed, okay? And as well as it is like a source of the electrical transformation, or complete the electrical circuit, okay? What is the agar? Okay, it's a wax substance, okay, that we can get it naturally. So it's found naturally, okay, we cannot like made it. It becomes liquid when heating it, and it is solid at room temperature. So it's like solid, but when it like the temperature gets up, it will melt, okay? So what is the reason of using it? So it's used for fixing, or does not like allow the electrolyte substance inside the salt bridge. So it's like something that we use to do not like let the electrolyte substance inside the like a bridge to like move. Okay. Now, this is the Daniel cell. As we mentioned previously, so we have two balls right here, or two containers at NSO4, and this is the Zn, okay? We have the Cu into CuSO4, and this is the bridge, okay? The salt bridge, okay? And we have right here the current or the switch. That's the current, the wire, the cathode, and the anode. Now, So the equation could be as follow. Write down the half reactions of the Daniell cell and indicate the general reaction of the cell. So we know for the Daniell cell we have Zn, okay, we have CuSO4, and you will be a transformation between these two. For the Zn, it's an oxidizing, it's a reducing agent or oxidizing agent. So it's oxidized, right? Because the Zn, it was 0 and it becomes Zn plus 2, which means that it gained 2 electrons. So the oxidation number of the Zn increased. For the copper, it was plus 2. It's reduced. Okay, it's an oxidizing agent. It gained, like, it lost 2 electrons or gained, well, it gained 2 electrons, right? And it becomes the Cu, okay? So this is the half reaction. So the reduction first, okay, and we have the oxidation second. And the general equation would be, you only gonna like cancel the electrons here with this electron here and write everything down. This is the general equation. So how does Daniell cell work? The process. So when the electrical circuit is complete, the half cell reaction of the oxidation or reduction begins spontaneously, as follow. So first of all, the half cell reaction or reduction, Zn pole anode, the first equation. So every zinc atom loses 2 electrons, as we mentioned, to give Zn plus 2. The electron transforms from the Zn pole through the external wire, and then it enters the copper pole solution. As we know, the Zn strip dissolves generally gradually, so it's like not all the time. I mean, it's like a step by step. It takes like some time to get it like dissolved and transform into a solid cover anode, and then the post, I mean, gets like in the bottom of the flask, okay, and then the result of the that it will be an increasement of the thickness of the cover. This is the first one, the half. What does happen inside the Daniell cell? So after a period of like time and after the transformation of the electrons from Zn atoms to the copper rod, the concentration of zinc ion will increase, as well as there will be like a shortage in CuSO4 solution, and this what will happen. Okay, the remaining SO4, as we mentioned, it will be like steady, or it will be like the negative ion in the road will transform to the salt bridge and to the ZnSO4 solution towards the anode. So this the bridge will be a transformation of this ion. Potassium ions, K plus, will transform from the salted bridge to the CuSO4 solution to treat the excess of the zinc ions.